In this video, I'll be taking a look at a fairly standard problem for continuous random variables which are normally distributed. So you can see the problem on screen right now. It says, given that x is normally distributed with a mean of 47 and standard deviation of 9, we're asked to find 5 different probabilities. Now, at first they all look pretty similar, but there are some slight differences in there. The first one here is probably the most fundamental question of all, where we've got the probability of x being less than some value. We then move to a slight complication where we reverse the direction and look for the probability that x is greater than a value. Then we look for x less than a particular number. We'll see why that's slightly different again later. And then there's 2 examples where we're looking for the probability that x is between 2 numbers. Now for this example, I'm going to be doing this using a cumulative normal distribution table. So I'll just give you a quick look at that. And I'll be using that explicitly here on the camera to show you how we figure these probabilities out. Okay, so the first problem we've got to look at is the probability that x is less than 52. And the way I always start these problems is to draw a little sketch of the normal distribution just to see with what we're dealing with when we're trying to answer the question. Because it's a normal distribution, we're going to have a bell-shaped sort of curve. And it's just a sketch, so it doesn't need to be perfect, but probably looks something roughly like that. Now, in our particular question, our mean is 47, and the normal distribution is always centered at its mean. And I'm not really worried about the standard deviation at the moment. But the particular value I'm looking for is the probability that x is less than 52. So 52 is going to be over here, definitely greater than the mean. And the probability that x is less than that will be given by the area that I'm shading in now. Now, because it's to the right of the mean, we know that the answer we get should be greater than 0.5. 0.5 would be the probability that x is less than the mean, and we're to the right, so we know we're going to get a greater area than that. Now, the first thing that I need to do is change to a standard normal variable. Now, that's because the probability table that I've got is written in terms of a normal distribution where the mean is 0 and the standard deviation is 1. So I'm going to start by transforming to the standard normal. So the probability that x is less than 52 will be the probability that not x, but z is less than the transformed version of 52. So 52, take away the mean of our distribution, which is 47, divided by the standard deviation, which is 9, which is the probability that z is less than 5 over 9, or the probability that z is less than 0.55 recurring. Now, to determine that, using our cumulative normal distribution table, we need to look up z equal to 0.55 on the table here. So the way this table works is we need to go down the column to 0.5 and then across to the 0.05 part. So that intersection of 0.05 and 0.5 gives us a probability of 0.7088. And that's approximate, it's rounded off. So I'm going to write it's approximately equal to 0.7088. Now, quick sanity check, that should be greater than 0.5, as I said before, and it is. So I'm okay with that, and I'll try to move on to the next part now. So part B, this time we've got the probability that x is greater than 60. So again, I'm going to start by drawing a quick little sketch of the situation. Again, it's a sketch, so it doesn't have to be perfect. Centered at 47, the mean in this problem, and 60, so a little bit further to the right than the previous question. And this time we're looking at the probability that x is greater than 60. So we need to shade in to the right of the value of interest. So you can see we'll be looking in this problem, hopefully to get an answer that's a bit less than 0.5. You can see the amount of area that we've shaded in there. Let's see how we do it. We're looking for the probability that x is greater than 60. Now what I'm going to do here is immediately think about it in reverse. I know that the table I've got gives me probabilities for x less than certain values. So I can't answer a question for x greater than a value. I need to turn it around into something that my table can help me with. So looking at the picture, okay, all of the probability of all the possible values is of course equal to 1. So if we have a piece over here greater than 60 and a piece over here less than 60, together those areas must be equal to 1. So we can figure out the shaded area by determining the unshaded area and then subtracting it from 1. So we'll end up with 1 minus the probability that x is, and this is important, less than 60. The probability that x is less than 60 is the unshaded area under the curve over here. So we want to figure that out, subtract it from the entire probability of 1, and that'll give us the answer we're looking for. Next thing I want to do is, recalling that my probability table is for standard normal, I need to transform my x to a z-score. So I'm going to have 1 minus the probability that not x, but z is less than the transformed version of 60, which is going to be 60 minus the mean, 47, divided by the standard deviation of 9. So that's 1 minus the probability that z is less than 13 over 9, or 1 minus the probability that z is less than 1.44 recurring. Okay, so now we're at a place where we can go to the table and figure out what this probability is. So we need to go to our standard normal table. Probability that z is less than 1.44 is going to be 0.9251. Jumping back to our problem. 1 minus 0.9251. And remember, that's a truncated, a rounded off value. So we're actually orbits there, and this will be an approximate response. So we're going to have, we do that subtraction, an answer of 0.0749 approximately. So the probability that x is greater than 60 is around about 7%. Quick check of our picture up here. It's quite a small piece of area under there. So around about 7 or 8% seems reasonable to me. Part C asks us for the probability that x is less than 40. So we're back to a less than probability, but this time the problem is actually that that number that we're looking for x to be less than is to the left of the mean. So I'll explain why that's a bit of an issue in a moment. So let's do a quick sketch. There's our mean of 47. Jump over here to around about 40. So we're looking for this area under the curve over here. Okay, and you can see we're to the left of the mean. So we're going to get a value which is less than 0.5 for the probability. Now the problem is that the standard normal table that I'm working with only gives me values of the probability for x being over on this side of the normal distribution. So for values that are bigger than the mean. So I need to figure out how to deal with it when we're on the other side of the curve where we're less than the mean. So the way that I go about these ones is I remember that the standard normal or any normal distribution is symmetric about the mean. So the curve on this side and the area under it is reflected, or the mirror image of the curve on this side and the area under that. So if I, instead of going 7 below the mean, go 7 above the mean to a value of 54, and look at the area above 54, symmetry tells me that those two values should be the same. Now, it doesn't look quite like it's quite working on mine because my sketch is a bit rough. But the idea is that the curve is symmetric, so these two areas here should be equal to each other. So that means that I can say the probability that x is less than 40 is equal to the probability that x is greater than 54. Now just remember the reason why I've used the value of 54 is because I'm looking for symmetry. 7 below the mean, 7 above the mean. So 47 plus 7 is 54. So now I'm on the correct side of the mean, but the problem now is that I'm looking at a probability where we're greater than some value. Now remember from the previous example that to figure out the probability when I'm greater than some value, I need to look at the probability that I'm less than that value and subtract it from 1. So I'm going to have that the probability that x is greater than 54 will be equal to 1 minus the probability x is less than 54. The probability that x is less than 54 being all of this shaded area over here. So I need to subtract that from the entirety of 1, which will leave me with the red portion here. Now I've got something that I can actually get from my table once I standardize or normalize the values. So we continue 1 minus the probability, this time of z less than 54 minus the mean divided by the standard deviation, which is 1 minus the probability that z is less than 7/9, or 1 minus the probability that z is less than 0.77 recurring. At this point, we can go to our cumulative normal distribution table and look for 0.77. So 0.7 and across to 77. We have a probability of 0.7794. 1 minus 0.7794. Remember, that's rounded off. So we're going to have an approximate result of 0.2206. Part D of the problem asks us to find the probability that x is between 49 and 55. As usual, let's take a look at a quick sketch of the situation. Again, with a mean of 47, we're looking for x between 49, just slightly higher than the mean, and 55, a bit further along. So it's something like the area that I'm shading now. So to determine the answer to problems like these, what we're going to do is separate it into two pieces. So effectively, we'll be looking at the area under the curve, or the probability for x less than 55. So that's all of the area under the curve here. And we're going to subtract from that the area under the curve for x less than 49, all the way back across here. So provided that we do that, we'll have all of that area, subtract that piece of area, and that'll leave us with the piece that's shaded in our graph here. So that's this little piece in here. So to do that, we're going to write that we have the probability that x is less than 55. We're going to subtract from that the probability that x is less than 49. So both of these are less thans, so we can use tables, particularly because they're both to the right of the mean of the distribution. All we need to do is transform them into standardized form. So we'll have the probability that z is less than 55 minus the mean 47 divided by standard deviation of 9. And the same for x of 49 will become z less than 49 minus 47 over 9. Let's clean those up a little bit. Z less than 8 over 9 minus the probability that z is less than 2 over 9. Now into some decimal form so that we can use our table. We're going to have the probability that z is less than 0.88 recurring. Take away the probability that z is less than 0.22 recurring. Now we can jump over to our tables and search up the values for each of those. 0.88, we have 0.8106. Subtract the probability that z is less than 0.22, which is 0.5871. Just evaluating the difference there, we get 0.2235. So the probability that X is between 49 and 55, this small shaded region here, is about 22%. Reasonable enough, it's got to be less than 0.5, and there is a fair bit of area under there, so 0.22 seems fairly reasonable. Final problem, part E, asks us to find the probability that X is between 40 and 54. Now, sketching this situation, we have mean of 47. This time, the two values that we're looking for X between are across the mean. So we have 40 to the left and 54 to the right. Now, what you might remember is that when we're on the left-hand side, we have to do a bit of work to get that into a value that we can look up in our tables. 54 is fine, we'll just standardize that, but we do need to do a little work on 40. So we're looking for the area that I'm shading now. And we're going to write that just like we did in the previous example as the probability that X is less than the larger value, 54. Take away the probability that X is less than the smaller value of 40. And we're using the same reasoning there as we did to subtract the areas in the previous example. Okay, now to do this one, we're fine to go straight to standardizing 54. But we need to work on this one first. So I'm going to do that before I change to the Z variable. So I'll leave the first one as the probability that X is less than 54, just for now. And you might remember that the probability that X is less than 40 is exactly what we did in part C of this problem. Now in part C, we need to change that to a problem on the other side of the mean. And what we did was we rewrote this as the probability that X is greater than 54. Now that's not because 54 is mentioned in this particular part of the question. It's because 54 is the number on the other side of the mean, which is exactly the same distance away as 40. 7 below, 7 above. Next, we need to rewrite this red piece so that it's a probability which is less than something. So again, leaving the first part, probability that X is less than 54. We then have to subtract, not the red piece, but 1 minus the probability that X is less than 54. Now, this is because the probability is greater than the probability that X is greater than some number is 1 minus the probability that X is less than that same number. So continuing on, there's a bit of simplification we can do here. We've actually got minus minus makes it plus. We actually have 2 of the probability of X less than 54. And we're going to subtract 1 from that, minus 1. Now we can move to standardizing or normalizing our X value. So we have 2 times the probability that Z is less than 54 minus 47 divided by 9. Take away 1 remains the same. That's 2 times the probability that Z is less than 7 over 9, or just straight to 0.77 occurring. Take away 1. Now we can go to our tables, or you can simply refer back to part C of the problem to note that the probability that Z is less than 0.77 is 0.7794. We have 2 times 0.7794, and now take away 1. Evaluating those, we have 1.5588 minus 1, which is giving us a final result, approximately 0.5588. Okay, so that's the probability of the area of the shaded region here, or the probability that X is between 40 and 54. Okay, so that's a few different little problems that we can work with when we have a normally distributed random variable and we're trying to figure out some probabilities using a standard cumulative normal distribution table.